Hey guys, today we are starting chapter 4, which is all about writing equations of lines. Specifically here for 4.1, we're looking at writing equations of lines in slope-intercept form. So just as a reminder, in case we forgot, slope-intercept form, we know that y equals mx plus b is what that equation looks like, and we know that in this case, our m is our slope, and b is our y-intercept. So if I'm writing the equation of a line in slope-intercept form, I just need to know what those two things are, and I can substitute that into my equation. So in this case, if I know that my slope is -2 and my y-intercept is +5, well, -2 goes in there for m, +5 goes in there for b, and your y equals -2x plus 5 is your equation. If we try that again real quick, just to make sure we're good on this, with a slope of 1/2 and a y-intercept of -4. Plugging that into our equation, we end up with 1/2 x and then -4. Technically, you could put -1/2 x plus -4, but we usually just make a negative slope or a negative y-intercept, a minus on my equation. Okay, another way of writing our equation from slope-intercept form is from a graph. Now, from a graph, you're going to have to interpret what those two pieces of information are, what my b is and what my m is. That's still our goal, is finding what those two things are. In this one, the easy thing to start with, just like if we were graphing a problem, is identifying my y-intercept. Now remember, the y value of the point where my graph crosses the y-axis is my y-intercept. So that tells me in this case that my b is +3, which eliminates c and d. It's either going to be A or B because those two have a +3 for their B values. So what you have to do now is figure out what the slope is. So in this, I've got a second point here, and I can just do the easy way of doing slope triangles. I'm going down 2 and right 5. Now remember, our slope is rise over run. So in this case, my rise was -2. My run was +5, which is why A is the correct equation for that graph. It has a y-intercept at +3, and it has a slope of -2/5. Okay. If you know, so again, that's direction number 2. That's way number 2. If you've got 2 points on your line and one of them crosses the y-axis, you can use the intercept and then those 2 points to find the slope. I think it's easier from the graph, especially from the graph, to do, just do kind of rise over run on your slope triangles. If we're given 2 points, just 2 coordinates, we can still do the same thing. Here, I'm still aware that anytime my x value is 0, that y value is my y-intercept. So in this case, -5 is my y-intercept, even though I don't necessarily see that it crosses the y-axis, if I was just given the coordinates. And then to find my slope between those 2 points, remember we didn't really use this a whole lot last chapter, but now it's coming back for us. Our slope formula, y2 minus y1 over x2 minus x1. Basically, again, just subtracting your y values up top, subtracting your x values in the bottom. Order does not matter as long as you guys keep it consistent. So here, if I did 2 minus -5, if I started with 2 in the y values, I have to start with 4 in the x values, because 4, 2 is the coordinate that I'm working with here. So now subtracting -5 is like adding 5, so I have 7 over 4, because 4 minus 0 is 4. You get the same thing if you went the other order. -5 minus 2 is a -7, 0 minus 4 is -4, so -7 over -4 reduces to a +7 over 4. So we have our slope, we have our y-intercept, so we're just going to put it together. 7 over 4x plus -5, which really I would probably write it as y equals 7/4 x minus 5. That's how I would write that one. Your x value here, when you have a fraction for your slope, I always just keep it next to it. I leave my x value separate from it. If you're going to combine them together into just a single fraction, the only correct way that you can write that would be y equals 7x over 4 minus 5. The x can either stay in the denominator or sorry, stay in the numerator or right next to it. But this right here is how I usually write my answer. Okay. So if we give it a try here again, just going from our graph, I can see right here at -2, that's my y-intercept, so I know that b is -2. And then simply, since I already have my graph, doing my rise over run, I'm going up 1, 2, 3, 4, 5, so +5. My run is +3. That tells me my slope is 5/3, both positive because they're going up and right. So my equation would be y equals 5/3 x minus 2. Okay. That's most of the problems. There is a third way, a third thing that we'll see. And this one is going back to function notation, so making sure that we understand that a line is really just a function, right? A linear function is a line. So we can use slope-intercept form to write the equation of that function. So the way the information can be presented to us can be a little bit different because I'm given information in function form, which, remember, function notation, this was f of x equals y, right? My input and my output are found in function notation. So if I was going to change those two coordinates, f of 0 equals 5 tells me when my x value is 5, my y value is, or sorry, when my x value is 0, my y value is 5. So I have this coordinate from that function notation. And the same thing, f of 4 equaling 17 tells me that when x is 4, 17 is my y value. So I have this other point. And then from there, it's just like we did in the last problem. So you can either plot those 2 points to find your slope using slope triangles, or you can always use your slope formula for that. If I do that here, I'm going to start with 417. So 17 minus 5 over 4 minus 0 gives me 12 over 4. I don't like where I put those lines there. Gives me a slope of +3. So slope is 3. From there, we also know since 0, 5 was one of my points, my x value is 0, my y value is 5. 5 is my b value because my y-intercept is always when x is 0. So again, here, we're going to write the equation using a slope of 3 and a y-intercept of 0, 5. That is 3x plus 5. Now, if it's given to you in function notation, we should actually do one step further. If we're giving our answer in a function notation, all we have to do is make sure we remember that, draw all the way across here, we know that f of x is the same thing as my y value. So if I wanted to really do this in function notation, we have f of x equals 3x plus 5. And that would be my final answer for that one. Okay, on to our real world situations, so our word problems, basically. We know that y equals mx plus b can be used to model a lot of real life situations as long as that y value changes at a constant rate with x. You know, because again, a linear function, we talked about that when we were looking at identify if something is linear or nonlinear. We have to have that constant change in y and that constant change in x. So if we have that constant rate of change, we have a linear function. We can write a linear equation with y equals mx plus b being that equation. In here, that m, my slope, that represents that rate of change. So whatever rate my situation is dealing with is going to be my m value. The b value here, I didn't really say this, my b, which we know is my y-intercept, is always a starting value or an initial amount, something like that in these word problems. Because if my y-intercept is where my line crosses the y-axis, that's when my x value is 0. That's where we start. So we have a starting value, that's my y-intercept, that's my b. My rate of change is going to be my slope, is my m. So let's take a look at a couple of problems here. I'm just kind of going through these real quick. A recording studio charges musicians an initial fee of $50 to record an album. Studio time costs an additional $35 per hour. We're asked to write an equation that gives the total cost of an album as a function of studio time in hours. Find the total cost of recording an album that takes 10 hours of studio time. So I've taken that and broken it down into a bunch of different problems here. So we're asked to write an equation that gives the total cost of an album as a function of the student time. Function of the student time. I think that's supposed to be studio time. That's a typo there. So important information here, just highlighting our numbers. We've got those three numbers in there. $50 is the initial fee. Again, you see that little phrase there, initial, kind of hinted at you that that's going to be our B value. That's our starting rate, or our starting value. If you see this word per, it's not a very common word in terms of using it just in general, other than talking about a rate. Per represents a rate. So if we're looking for a rate of change, $35 per hour is the rate at which we're charged. So that number 35 is our per, that's going to be our slope, that's our M value. That initial fee of $50 is going to be our B value. So in here, just kind of leading, like those leading questions in the value, what problem, the value in the problem stays the same no matter how much you spend at the time of the studio. That's that $50 studio fee. What value changes depending on how long you're there? $35 per hour. So again, just kind of leading questions here. Which one do you think is the y-intercept? Oh, it's going to be the $50 because that's the starting one. The slope is the rate of change. We know that's the $35 per hour. So again, we'll jump into our equation. So now that we know $35 per hour is our rate, y equals 35x plus that $50 starting fee, just to get into the studio. So that's our equation. So y equals 35x plus 50. Now they're asking us to find the total cost of recording an album that takes 10 hours of studio time, which if x represents our hours, y equals 35 times 10 plus 50 gives me y equals 350 plus 50, so 400. $400 to record that album that takes 10 hours to do. All right, that's a little bit of everything. The homework right there is on page 179. You guys are doing 4 through 24 evens. As always, if you have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. I'll see you guys soon.